So I wanted to talk a little bit today about some of the internal changes that have happened in jQuery 1.4. In the release, we did a lot of restructuring and a lot of rewriting of the code base. One of the big changes that we did that won't immediately affect you, but it is really important, is just that we've set up a core style guideline for jQuery. And so this is more for the internal development and making sure that the code base has a unified code formatting to it. But this is it's really indicative of the larger amount of work that we've done in this release. And we've tried to go through and really make sure that the code base is as clean as possible. So a couple of things that I wanted to talk about today are things that we've done to improve sort of the cleanliness of the code base, while at the same time reducing some of the complexity. One of the big things is that we restructured a lot of the code base. We split core.js. So jQuery has all its internals in different modules. But core.js was really quite large before, and it included a lot of different concepts, including traversing and manipulation, CSS attributes, stuff like that. We took all that and split it up into many different files. And in doing so, we got a better understanding of the sort of complexities that exist there, and we were able to reduce a lot of sort of the problems that exist, or reduce a lot of the complexity in the intermingled code base. So in a lot of ways, you should find that the code base is not only easier to read because of syntactical changes, but also easier to understand because of this reduction in complexity. One thing that we're moving towards, though, is having sort of the core.js represent the very absolute core and best functionality in jQuery, from which you can build everything else. So to get to that point, we moved the ready event from event.js into core.js. And we're looking to sort of do this with other functionality. Before 1.4 came out, we were playing around with a method called require, which would allow you to load JavaScript files remotely. And we're considering having that be in core.js if we do eventually land that. So another thing that we worked on was making it so that whenever we do compression of the jQuery files, we are now using the Google Closure compiler. And historically, we've been using YUI-min. And in testing out the Google Closure compiler, we were able to get some really big speed benefits from switching to it. So not speed, but really large file size benefits, and that we were able to reduce the entire file size of jQuery by 13% after minification and gzipping, and that's really quite outstanding. And we're very pleased with this switch. We should note, though, that the Google Closure compiler is very different in a lot of ways from YUI-min and other tools of that sort. The big difference is that the Google Closure compiler is optimized for compressing multiple files simultaneously. And when you do that, when you put multiple files together, the Google Closure compiler is able to strip out extraneous methods and functions that aren't being used. So in that way, you need to be sure, you need to be very well aware of what settings you're using when using the Closure compiler. For jQuery, we're just using this simple optimization mode, and that is enough to reduce the file size significantly for us. One method in jQuery that's new that we created, and it's been rewritten a couple times now, but the final rewrites were done by Robert Caddick, and it's called isPlainObject. So isPlainObject is a way of detecting if an incoming object is actually was created typically using an object literal when it was first defined. And it's very we found a number of places in jQuery where this is very useful for us. So this is very distinct from determining if something is just an object itself. Because, like, for example, null is considered to be an object, and DOM elements are considered to be objects, and so I mean there's a lot of things in there that we don't want to consider, that we only exclusively want to consider, the very plain objects that exist in JavaScript. So when we worked on this method, we wanted to make it so that ultimately, when we were doing extending of jQuery, using the deep extending in jQuery, that we were able to do it in such a way that it would cause less conflicts. Now, what that means is that when we were doing the deep extending previously in jQuery 1.3.2 and earlier, we were hitting problems when the extend method would try to extend objects like DOM elements and window objects, which it doesn't really work, and it starts to traverse way too deep and gets really confused. So since we had this isPlainObject, we were able to develop a better jQuery deep extend, and it's able to work in a way that is it has a better chance of doing what you expect it to. So we're really quite pleased with this change. Another change that we made is a rewrite of the jQuery browser detection. Now, I should continue to make clear that we definitely do not want you to use the browser detection code, and that we would much prefer if you used feature detection. And you can see a number of examples of that in the jQuery support object and throughout the jQuery code base. But one of the bugs that was coming up with the browser detection, and especially with jQuery.browser.version, was that it wasn't very obvious what version we should be extracting from the user agent. So one of the changes was that we only check the version now based upon what rendering engine was detected, and this has made the code a lot more resilient and ultimately a lot. It's much better able to give the correct version now. So this is another change that has solved a number of outstanding bugs. One additional benefit is that since we now have sort of a generic method for determining the rendering engine and the version from a user agent string, we can now have a very efficient test suite. And so we set up a full test suite to cover jQuery browser, and we included a large number of user agent strings. And so we now have a very excellent coverage of jQuery browser, and making sure that it works correctly. Another change that we found to provide some really large speed benefits, and we alluded to in the release notes when we talked about the improvements to append, prepend, etc., is we construct DOM fragments in jQuery internally to store the HTML that you're inserting into the page. So if you're trying to insert, let's say, a number of LIs into a UL, the change that we made is that, I should say the change that we made in 1.3 is that we take that LI, the LIs, and we put it into a DOM fragment. But we found that if we could take that fragment and we could cache it for later, if you're going to go through and insert many LIs, that it actually becomes much faster. And since we don't have to recreate those DOM nodes again and again, we can just clone it. So we end up with this a very efficient caching code. We set some limitations on it in that we only do it if it's about a half a K, no more than half a K in size. And we only create the cache if there are multiple attempts to insert that particular string. So it's, but this code alone has been just great for some immediate performance benefits. Then we have a method internally called access that we are using in the CSS and attribute methods. And one thing that we found when optimizing those two code areas is that it was very much they had the same exact style of signature, and that they could both take a name and return a value, or they could take a name and a value to set it, or they can take an object of name and values. And so we distilled all that functionality into this one access function that we use internally. And so this may be something that we'll expose at some point for plugin developers, but at least for now, we found it to be very helpful in reducing that complexity that exists. Another method that we created that tackles the same exact sort of reduction of complexity is between the not and filter methods. Both of those methods behave rather similarly, and we found that if we extracted that functionality into a separate function, that we were able to reduce complexity rather well. So we called it winnow. Yehuda Katz created this originally. It's because it's all about paring down the results to your final result set. And so in this way, you can filter down by element. You can filter by selector, by jQuery set, by function, all these different things. So it's really just a great method for again reducing that complexity and reducing the amount of duplicate code. And in this way, we were able to get much better API parity in between filter and not. There were some discrepancies before, and now they're completely identical. So this is some of the things that I wanted to talk about, some of the changes in jQuery 1.4 in the internals. And if you have any questions, please feel free to hop onto the jQuery development forums and ask us. The jQuery team is always there. And thanks again, and I hope you're enjoying jQuery 1.4.